test, no one talk. For the next test, you must memorize the mean value theorem. Okay? For the next test, you must memorize the mean value theorem. The theorem is how should I say? The theorem is most easily memorized as a picture. I think it's a lot easier to memorize the picture than all the words. So don't write anything down yet. Make sense of this picture. You have a function. Okay? In this problem, the function they're referring to is this one, y equal root x. So if you don't remember, it's not a big deal, but this function happens to look like this. Okay, roughly. It's not crucial that you remember that. Don't stress about that. This is this function, okay? Just say out loud, please. How many different slopes are there on this function? Say it. Okay, cool. Now, if I go from this point, though, 0, 0, to this point over here, which we'll refer to as being 4, 2, between the 2 points, there's only one slope. Okay? That's the secant slope. So there's an infinite number of tangent slopes. There's only one secant slope. You all with me? Okay. The mean value theorem states, and you can abbreviate it. MVT is a valid abbreviation on the AP test. So mean value theorem says that as long as this function is both continuous and differentiable, those abbreviations are not valid. You'd have to spell that out. But for your notes, this is handy. So as long as the function is continuous and differentiable, then the theorem guarantees that at least one of these tangent slopes will be exactly the same as the secant slope. Okay? You can see it in the picture. About here, the tangent appears to be the same. Okay? That's dang good. That is really dang good. Dang good. Especially for a guy who went home yesterday during school for the first time in 16 years. So I lost my record. Cal Ripken and I. So nobody knows who Cal Ripken is. We do. No, I don't. I hate to miss school. I just, third period yesterday, it was not working well. So.
Third period broke your record.
Yeah, 16 years, but you know, start over again. So, questions here? Okay. Very good. Awesome. Okay, that's the mean value theorem. Another way to memorize the mean value theorem is the average rate of change, because secant slope means average rate of change, will be exactly the same as one of the instantaneous rates of change. At least one. You could have more. Any questions on the theorem? The theorem is really very simple. Just memorize the picture. It's really easy to memorize. Okay, this problem is saying the mean value theorem guarantees that somewhere in here there will be a tangent slope whose value is the same as this secant slope. And they want to know where. Where does that happen? So it's a classic AP problem, meaning you're not supposed to do this step by step. You're supposed to look at the concepts and apply them. My thought is, well, if one of these tangent slopes matches the secant, maybe I should find the secant first. I can do that very quickly because I can say, let's see, I've got this table. This is root x. So when x is 0, this is 0. When x is, oh, they've already done it for me, sorry, my bad. When x is 4, this is 2. So the secant slope's really simple. Change in x is what? Say it. Change in x here is 4. What's the change in y? 2. So the secant slope is 2 over 4, 1/2. Question? So the secant slope is 1/2 on that interval. Therefore, mean value theorem guarantees one of the tangent slopes will have a value of 1/2 as well. So we take the derivative of our formula. So we take the derivative of root x, 1 over 2 root x. Okay? This is a formula for finding any slope on the curve. I'm trying to figure out where on the curve will the slope be equal to 1/2. So we say we want 1 over root 2 to have a value of 1/2. Okay, it really helps if you can learn to solve equations by looking at them, not by manipulating. Just look at it. These have to be the same. That's what equal means. So just raise your hand and you can tell me what value must x have that will make these the same. Like, don't do algebra. Just raise your hand. Don't go right to algebra. It's far better to kind of look at it and go, oh, I can see it. And then if I have to use algebra, I use algebra. But all the algebra is to make it so I can see it. You can see it. Come on. What value of x will make these the same? Hands. Oh, the square root of -1 is imaginary, so don't do that.
Sorry, 1.
How many knew it was 1? Yeah, point. So at x equal 1, so over here, so my drawings, my curve isn't quite correct. At x equal 1, the slopes will match. Question. That is the mean value theorem.
That's pretty easy.
So that's it. Please, Mark.
Will there ever be an instance where, like,
No one talking.
multiple options?
No one talking. Can't hear. Start over.
Will there ever be an instance where, like, multiple answers will have the x coordinate as 1?
Oh. So being a function at an x coordinate of 1, there can only be one y coordinate that works. So you just plug it in. You say, oh, here's my formula. So if the x coordinate's 1, square root of 1 is 1. They could definitely have more than an x coordinate of 1 here, for sure. 2 points. Good job, you guys. Well done. Those should be the only 2 new ideas in the packet. Everything else is review again, so it's getting you very used to AP problems.
Wait, can you go back to the last one?
Look at me, please, before the bell rings. Say, look up. Look up. Before the bell rings, look.